Now what we're going to do is we are going to apply similar triangles to actual word problems. Okay, so 7.2, use similar triangles to solve problems. So similar triangles can be used to measure distances that are difficult to measure directly. Okay, so in example 1, we see a stream, like a river. Okay, so determine the width of the river, so the distance between like W and M, right? Maple and Willow. We call that X. So what we know is sumac to B. So let's call this A, B, and then we'll call that S. And then B, and then we'll call that M and W. Okay? So we know that triangle ABS is going to be similar. So AB, WBM. Triangle WBM. Okay? And we have to order them in that order. A is that up at the top. B is going to be congruent to B because that's opposite angles theorem. And then M and S are going to be 90-degree angles. Okay, so we know the lengths of SB and MB. So let's go ahead and put MB over SB. And we know that that's going to be 24 over 9.3. Okay, and then we want to know X. And we know 8.4, which is AS. Okay, so X over 8.4. So now we can just go ahead and solve. Okay, so we can go 24 times 8.4 divided by 9.3. And that's going to equal our X. So we go 24 times 8.4 divided by 9.3. And we get X equals 21.68 approximately. Okay, and that's going to be in meters. Okay, so we can say therefore it is 21.68 meters from Willow to Maple. Okay, so the difficult thing here would be to actually measure the distance across the river, but instead we can take two distances and similar triangles. Okay, next, sometimes with two similar triangles, the smaller triangle and the larger triangle share an angle. Okay, and we've seen this before, but now let's actually put it into a word problem. So the smaller triangle is part of the larger triangle. Okay, so Ryan, who is 1.5 meters tall, is standing 15 meters away from a tall building. So this is going to be the building here. So this from here to here is 15 meters. Okay, a spotlight is on the ground located 20 meters away from the same building. So here's the spotlight. So this entire distance is 20. So then this would be 5, of course. You just do that subtraction. Okay, and it's important that the spotlight is on the same side of the building as Ryan. Okay, how tall is Ryan's shadow on the building? Okay, so Ryan's shadow is going to be, maybe the building's even taller. Okay, but Ryan's shadow is going to be this height right here. So let's actually name these triangles. Okay, so let's go ABC and then DE. So we know that triangle ABC is going to be similar to ADE. ADE triangle. Okay, so the angles A and A are going to be the same, and then C and E are going to have 90-degree angles. So again, by default, we know that since A and A are the same and C and E are the same, then by default, B and D are going to be equal as well. Okay, so we need to find this height. We need to find DE. So let's make ratios with corresponding sides. I like the bigger triangle over the smaller triangle because then the ratio is nice. Or I like to do the unknown on the top. So the unknown is part of the big triangle. So let's put the big triangle on top. So let's go AE over AC, okay? AE over AC, and that ratio is going to be equal to BC, no, lying, DE over BC. DE over BC. Okay, so we're going to have 20 over 5. So that's beautiful because that's just 4. Okay, and then we don't know what DE is, but it's going to be over 1.5. So in this, what we want to do is we want to cross multiply. Okay, so DE over 1.5 cross multiply. We have 4 times 1.5 equals DE. We have 6. Okay, so the height of his shadow is 6 meters. Therefore, the height of Ryan's shadow is 6 meters. Okay, so it's important to know that the sun rays, or even like the rays of a light, like we saw in the previous example, are parallel. Okay, so if there are different objects, what's going to happen is, because these sun rays are going to go down at the same angle, they're going to make triangles or like shadows with the same angle. Okay, so the triangles formed by objects and their shadows are similar. In similar triangles, the heights, so this is the important part here, the heights or the altitudes are also the same ratios as the lengths. So we saw perimeters are also the same ratios as the ratios of the lengths. Now heights are as well. So let's determine the height of the pyramid. Okay, so when we talk about height of the pyramid, we talk about this right here. Okay, this is isosceles, so this 230 base can be divided into 2. 115 and 115. Okay, so what we have now is we have this triangle right here, so 2 meters high, 4 meters in length, and then we have this triangle right here, because remember, we need to keep that angle from the sun's rays, so we can't do like the actual triangle of the pyramid, but we can do the triangle that the sun's rays are on. Okay, so let's just redraw these and let's actually name them. So let's just name this A, B, C, and let's name this one D, E, F. Okay, so the height and the base always meet at 90 degrees, so we know that that's the same angle. And A and D are going to be the same angle as well, because the sun's rays are going to are parallel, so they're going to be shining at the same angle. So by default, C and F are also the same angle. So we can say triangle ABC is similar to triangle DEF. Now let's label these. What is 115 plus 179 for that base? I get 294. Okay, we're trying to figure out CB, and then we have 2 and 4 as the height and the base of the smaller triangle. Now let's stack. Okay, I'm going to put this question mark at the top just so it's easier to cross multiply. So let's go AB over DE is going to be equal to CB over FE. Okay, so I know that AB is 294, DE is 4, CB we don't know, so we're going to solve for CB, and FE is 2. So let's go ahead and cross multiply that. So we get 294 times 2 divided by 4. And if you need me to write that out, that's fine. 294 times 2 divided by 4, and that's going to equal the height CB. So we get CB equals 147 meters. So we can say, therefore, the height of the pyramid is 147 meters. And you can simply solve that by using the shadow and the angles of just any other smaller object. Okay, so let's recall from science. Plane or flat mirrors have the same angle of incidence as their angle of reflection. So let me just draw one for you. So if we have a light beam coming in at this angle, incident, okay, it's going to have the same angle of reflection. Okay, so keep that in mind. A clever outdoorsman whose eye level is 2 meters above the ground, that means he is 2 and a bit meters tall, wishes to find the height of a tree. Okay, he places a mirror horizontally on the ground 20 meters from the tree. So from here to here, it's going to be 20 meters. And finds that if he stands at point C, which is 4 meters from the mirror, so this is 4, not drawn to scale, from the mirror at B, so let's call this B, he can see the reflection of the top of the tree. So it's going to bounce down and then bounce up. What is the height of the tree? Okay, so just keep in mind that these two triangles are actually going to be the same because we know that in the corner we're going to have a 90-degree angle, so we're dealing with right angle triangles, and then B and B are going to be the same because we know that the angle of incidence and the angle of reflection is going to be equal. Okay, so we have a triangle on this side and it's simply 4 and 2, and it's CB, let's call this A, just to be easy. And on triangle on this side, and this is going to be B, so we have ABC, let's call this D and E. And what we want to do is we want to find out DE, we want to find out the height of the tree. Okay, so let's go ahead and make ratios. Let's say triangle ABC is going to be similar, ABC, so hypotenuse first, DBE, DBE. And if you actually notice, B is going to be the same angle, so B is going to take on the same place when we write like corresponding triangles. So it's going to either be, the B is going to either both be in the first place or the second or the third. Okay, so let's do, we're going to do the question mark on the top. Okay, so let's go DE over AC, which is just DE over 2. And let's go BE, which is 20, over BC, which is 4, and cross multiply. So bring that 2 up. I get DE equals 20 times 2 divided by 4, and I get DE equals, what is that, 40 divided by 4? I get 10. So therefore, the height of the tree is 10 meters.